3.5 million years ago, the largest predator the oceans ever produced vanished. A shark 60 feet long, jaws wide enough to swallow a person whole. A bite stronger than anything alive today. Science says it died. The fossils stop. The teeth stop falling. But 95% of the deep ocean has never been seen by human eyes. And sailors keep reporting things that should not exist. A black shape under a fishing boat off Mexico. Whale carcasses with impossible bite marks. Sonar pings the Navy refuses to discuss. If you love mysteries the textbooks cannot close, hit subscribe. Tonight we descend into the dark and ask the question scientists hate. What if it never left? The fossil record goes silent around 3.5 million years ago. One moment the rocks of every continent are full of giant black teeth. Then, in a single layer of sediment, they stop appearing. Forever. Scientists call this a clean extinction. A textbook ending. The kind of disappearance that closes a chapter in the story of life on Earth. But there is something strange about that ending. Megalodon ruled the oceans for nearly 20 million years. That is a longer reign than any predator in history. 20 million years of dominance, of perfect adaptation, of leaving teeth scattered across every warm coastline on the planet. And then, in what scientists call a geological blink, it was gone. No transitional fossils, no slow decline, no populations clinging on in remote corners. Just an apex predator at the top of its game, vanishing. When researchers first realized this, they were stunned. Animals at the top of the food chain do not usually go extinct quietly. They leave wreckage. Other species rebound. Ecosystems shift in obvious ways. Megalodon's disappearance left ripples scientists are still mapping today. The official explanation has changed many times. In the 1980s, scientists blamed cooling oceans. In the early 2000s, they blamed the rise of killer whales. By 2022, a new theory emerged, that great white sharks, smaller and faster, had outcompeted Megalodon for food. In 2023, another study suggested Megalodon was warm-blooded, and that its enormous metabolism finally caught up with it as the planet cooled. Each theory replaced the last. None of them are settled. The truth is, no one knows for certain what killed the largest shark that ever lived. And that uncertainty is exactly where the doubt begins. A diver off the coast of Florida pulled an intact Megalodon tooth from the seafloor a few years ago. The tooth was over 6 inches long. What stopped people in their tracks was its condition. The enamel was glossy. The serrations were sharp enough to draw blood. Fossil experts examined it and confirmed it was indeed millions of years old, preserved by the cold, dark water that protected it from the chemistry of decay. But that is not always the case with every tooth pulled from the deep. Some collectors and sailors have reported teeth that look too fresh. Teeth with no minerals soaked into them. Teeth that look like they fell out yesterday. Most of these claims do not hold up under scientific examination. A few of them do. And those few teeth have never been satisfactorily explained. In a museum drawer in Wellington, New Zealand, sits one such tooth. It was dredged up from the South Pacific in 1873 by a British research vessel called the Challenger. When tested decades later, the tooth appeared younger than it should have been. Far younger. By some estimates, only 11,000 years old. If that estimate is correct, Megalodon was alive when humans were already painting on cave walls. Scientists have since challenged the dating method. They say the result is almost certainly an error. Almost. That word, almost, is where this story lives. Because the deeper you go into the case for Megalodon's extinction, the more cracks you find. And the deeper you go into the ocean itself, the more reasons you find to wonder what might still be down there. The teeth are the first clue, and there are bigger ones waiting. Picture a school bus. Now imagine teeth on it. That is roughly the size of an average Megalodon, between 45 and 60 feet long. The very largest specimens, recently confirmed by a study from 2025, may have reached close to 80 feet. That is taller than a 6-story building laid on its side. For comparison, the great white shark from the movie Jaws was 25 feet long, and that was a Hollywood exaggeration. Real great whites top out around 20 feet. Megalodon was 4 times larger. A great white next to a megalodon would look like a dolphin next to a great white. Its jaws alone spanned roughly 9 feet across, 9 feet wide, and 11 feet tall, wide enough to swallow 2 adult humans standing side by side, wide enough to fit a small car. Inside those jaws were 276 teeth, arranged in 5 rows, constantly being replaced as the shark hunted. A single tooth could grow over 7 inches long, the size of a human hand from wrist to fingertip. That tooth alone weighed more than a pound. To picture it, hold up your open hand right now. Imagine that hand made of black, diamond-hard enamel with serrated edges sharp enough to slice through whale ribs. Then imagine 276 of them, all working together. The shark itself weighed somewhere between 50 and 100 tons. That is roughly the weight of 10 African elephants packed into one body. Yet, despite that mass, biomechanical models suggest Megalodon could swim faster than any living shark. Active, wide-ranging, capable of crossing oceans. This is not the kind of animal that just vanishes quietly. This is the kind of animal that should have left a trail no matter what happened to it. And in the deep places we have not yet explored, that question becomes loud. Because if even one population somehow survived, we would have a problem. A creature that big does not hide easily, or does it? As for most of human history, no one knew what Megalodon was. Sailors and farmers in coastal regions kept finding strange black triangles in cliffs and on beaches. Massive, shiny, sharp. Some thought they were petrified tongues of dragons. The Romans believed they fell from the sky during lunar eclipses. Native Americans used them as tools, knife blades, even jewelry. Medieval Europeans called them tungstones and ground them into powder as medicine. No one connected them to a living animal. They seemed too large, too impossible. Then in the 1600s, a Danish scientist named Nicholas Steno held one of these tungstones in his hand and noticed something. The shape was identical to a shark's tooth, just enormously, terrifyingly bigger. That single observation cracked the mystery open. A shark had once existed with teeth larger than any living predator's jaws could hold. Steno's drawing of a giant shark head, published in 1667, was the first time anyone had ever depicted Megalodon. He drew it from imagination, scaling up a great white's skull to fit the impossible teeth. He was off in many details, but the basic idea stunned the scientific world. For the next 2 centuries, Megalodon teeth kept appearing. They were found on every continent except Antarctica. They were found in deserts that used to be oceans. They were found in mountain ranges that used to be coastlines. The largest verified tooth ever discovered measures 7¼ inches long. It was pulled from the dirt in South Carolina by a fossil hunter named Vito Bertucci, who would later die diving for more. Today, the obsession has only grown. The hashtag for Megalodon has been viewed more than 3 billion times on social media. Every few months, a video surfaces claiming to show the shark alive. Most are basking sharks, easily debunked. A few are unidentifiable. But the teeth keep coming. Every year, more wash up on beaches around the world. Every year, divers pull them from rivers and sea floors that should have been picked clean centuries ago. And every so often, one is found in a place where no Megalodon should have been. A place far too deep, far too cold, far too recent for an animal that supposedly died over 3 million years ago. Those teeth are where the real questions start. Despite hundreds of thousands of teeth in museum collections, no one has ever found a full Megalodon skeleton. This sounds impossible. The largest predator in ocean history, alive for 20 million years, and we have nothing but teeth, and a handful of vertebrae? Why? The answer is unsettling. Sharks do not have bones. Their entire skeleton is made of cartilage, the same flexible material in your nose and ears. Cartilage rarely fossilizes. When a shark dies, its body softens, breaks apart, and dissolves into the water within weeks. The teeth survive because they are coated in a mineral harder than bone. The vertebrae sometimes survive because they are heavily calcified. Everything else returns to the sea. This means that even today, after centuries of digging through every cliff and quarry on Earth, scientists have only ever recovered 2 near-complete vertebral columns from Megalodon. One from Belgium, one from Denmark. Both date to the Miocene, between 15 and 10 million years ago. Neither is from the period right before Megalodon's supposed extinction. That gap in the fossil record is the part that bothers some researchers. If Megalodon really vanished 3.5 million years ago, you would expect a final flurry of fossils right at the end. The way mammoths left enormous bone beds in Siberia. The way dinosaurs left layers of skeletons just beneath the asteroid impact line. Megalodon left almost nothing. The teeth thin out and stop. There is no concentration of late Pliocene specimens. No final Megalodon graveyard. The shark just disappears from the record, with no obvious reason for the silence. Some scientists argue this is because the warm coastal waters where Megalodon lived were shrinking. Fewer pups meant fewer teeth. Fewer adults meant fewer whalebone bite marks. The fossil record went quiet because the population was dying. Others have a different idea. What if the surviving population simply moved out of the warm shallows that humans later excavated for fossils and into deeper waters where dead sharks would sink into trenches no excavator will ever reach? In 2023, the research vessel RV Investigator was scanning the seafloor near Australia when it discovered something nobody expected. Nearly 17,000 feet down, in pitch darkness and crushing pressure, a graveyard of shark teeth covering the sediment. More than 750 teeth in a single small area. Among them, the teeth of Megalodon's closest known ancestor. That graveyard was not on the warm coastline where the textbooks say these sharks lived. It was in the deep abyss, where no Megalodon was supposed to be able to survive. The discovery did not prove anything. The teeth were ancient. But it proved one quiet, unsettling thing. The deep sea has been hiding Megalodon teeth from us this entire time, and we do not know what else it is hiding. To understand why Megalodon's potential survival matters, you have to understand what it did to anything in its path. Modern great white sharks bite with a force of around 4,000 pounds per square inch. That is enough to sever a seal in half. It is one of the most powerful bites in the modern ocean. Megalodon's bite force was estimated at over 40,000 pounds per square inch, 10 times stronger than a great white, 3 times stronger than a Tyrannosaurus rex. The most powerful bite of any animal ever known to have lived on Earth. To picture it, imagine an industrial car crusher attached to a jaw and aimed at you. That is what every prey animal in the Miocene oceans had to live with. What did it eat? Whales. Not small whales, large ones. Scientists have found whale ribs and skulls with Megalodon teeth still embedded inside the bone. Whales 50 feet long with crushing bite marks in their rib cages. Whales whose vertebrae were sliced clean through. Researchers studying these bite patterns made a chilling discovery. Megalodon did not attack the way great whites do. A great white bites the soft underbelly of its prey, then waits for it to bleed out. Megalodon bit higher. It targeted the heart and lungs. It went straight for the most vital organs, smashing through ribs to reach them. This was a precision predator with a bite of a wrecking ball. A study from 2025 used isotope analysis on fossilized teeth and found something even more disturbing. Megalodon was not picky. While whales were the main course, the chemistry of the teeth showed it ate everything it could find. Sea cows, dolphins, sharks, large fish, and probably anything else that swam past. To fuel its enormous body, it needed roughly 100,000 calories per day. That is the calorie equivalent of 300 cheeseburgers every single day for an animal that lived as long as 40 years. Now picture this body somehow surviving in the modern ocean. Where would it find that much food? Scientists who argue Megalodon could not have survived in the deep sea always come back to this point. The deep ocean does not have enough large prey to support such a massive predator. There are no pods of whales drifting through the abyss. There are no schools of large dolphins. But the people who keep the door open have a counter-argument. The deep ocean does have something the surface dwellers rarely see, and that something is what the next chapter is about. Because we have only just begun to understand what lives in the dark. Megalodon was not a creature of the deep, not originally. Every fossil tooth ever found tells the same story. It lived in the sun-soaked coastal waters of the warm tropics and subtropics, the bays, the shallows, the narrow strip of ocean between the open sea and the shore, anywhere the water was warm enough and full enough of life to feed it. Scientists have mapped Megalodon teeth across the entire planet, and the pattern is unmistakable. Every continent except Antarctica, mostly within 50 miles of an ancient coastline. Most teeth are found in shallow marine sediments, layered between fossilized shells, sea cow bones, and the remains of small whales. This was a creature of light and warmth, not darkness and pressure. For nearly 20 million years, this strategy worked perfectly. Warm coastal waters were rich with prey. Whales calved in the shallows. Dolphins gathered in pods. Schools of fish thickened the water. Megalodon cruised these regions like a king patrolling its kingdom, fat with food, untouchable, unchallenged. Its lifestyle had one problem, though. It depended on the climate staying warm. Around 5 million years ago, that started to change. The poles began to freeze. Glaciers crept south. Sea levels dropped. The tropical bands where Megalodon hunted began to shrink. Not all at once, but steadily, over millions of years. The warm coastal nurseries where its pups grew up disappeared one by one. Coastlines that had been balmy reefs became cold, gray water. Most scientists believe this is what killed Megalodon. Its habitat collapsed beneath it. Its prey moved or died out. Its young had no safe places to grow large enough to feed themselves. But here is what the textbooks rarely mention. The collapse was not total. Patches of warm water survived. Equatorial currents kept some regions hot. Volcanic island chains created pockets of stable temperature in otherwise cooling oceans. And along the edges of the deep abyss, in places where tectonic vents pumped warm water into the sea, isolated ecosystems continued to thrive. Could a small surviving population of Megalodon have followed the warmth? Drifted out toward these refuges? Adapted, slowly, generation after generation, to deeper and stranger conditions? It is exactly the kind of survival story we have seen with other species. Coelacanths did it. Frilled sharks did it. Goblin sharks did it. All three were thought to be long extinct. All three turned out to be alive in deep, dark, isolated waters. For now, science says no. The fossil record is too clean. The biology too unlikely. The food too scarce. But the same science said no about the coelacanth, until a fisherman pulled one out of the Indian Ocean in 1938 and changed everything. The climate that killed Megalodon may have driven it somewhere we have not looked yet. And the place we have not looked is most of the ocean. The dying did not happen in a single year, or a single century, or even a single 1,000 years. Megalodon's extinction unfolded across roughly 2 million years, from about 5.5 million years ago to 3.5 million years ago. During that long stretch, Earth's climate was rearranging itself. The ice caps were forming. ocean currents were changing direction. Continents were drifting into new positions. The world Megalodon had ruled was dissolving around it slowly, like sugar in cold water. The biggest single event in this collapse was the rise of the Isthmus of Panama. For most of Megalodon's reign, the Atlantic and Pacific Oceans were connected through a wide gap in Central America. Warm tropical water flowed freely between them. Ocean life mixed. Currents stayed predictable. Then, around 3 million years ago, volcanic activity pushed the seafloor upward, and a new strip of land emerged. The two oceans were sealed off from each other. The consequences were catastrophic. The Gulf Stream intensified, carrying heat northward and freezing the North Atlantic. Equatorial waters lost their connection to global circulation. Cold currents reorganized themselves around new patterns. Animals that depended on the old flow suddenly found their food gone, their migration routes blocked, their breeding grounds uninhabitable. Marine biologists call this period the Pliocene marine megafauna extinction. Roughly a third of all large marine animals went extinct during it. Whales, sea cows, sharks, seabirds. The ocean lost its giants. Megalodon was the biggest casualty. But here's the strange part. Not every giant died. Sperm whales survived. Killer whales survived. Great whites survived. Several other large sharks made it through the bottleneck. The ocean did not lose all of its apex predators, just most of them. Why did Megalodon, of all species, fail to adapt? It had survived earlier climate shifts. It had ridden out at least 2 previous cooling events without going extinct. Why did this one finish it off when the others had not? The honest answer is that scientists are still arguing about this. Some say it was the food. Some say it was the cold. Some say it was the rise of competitors. Some say it was a perfect storm of all three. A few researchers have proposed something stranger. They suggest Megalodon might not have died completely. They argue that small, isolated populations could have followed warm water refugees into deeper habitats, adapting, shrinking, becoming harder to find, becoming, eventually, almost invisible. These researchers are a minority. Most marine biologists dismiss the idea politely and move on, but the minority exists, and they have one piece of logic that is hard to argue with. When climates collapse, species rarely die all at once. They retreat. They hide. They wait. They sometimes wait for millions of years. Scientists have a name for these animals. They call them living fossils. We have already found several of them in the deep ocean, and we keep finding more. In 2022, a study from researchers in Germany made a quiet but explosive claim. By analyzing the chemistry of teeth from both Megalodon and ancient great whites, they showed that the two predators were eating the same prey: whales, dolphins, fish. The same animals, in the same waters, at the same time. That overlap might sound minor. It is not. In ecology, when two predators compete for the same food, one of them usually loses. The great whites were smaller, faster, more agile. They needed less food. They could reproduce more quickly. Their pups grew up in similar coastal nurseries to Megalodon's pups, which meant baby great whites and baby Megalodons were sometimes hunting in the same waters. If a baby great white met a baby Megalodon, the great white probably won. Not by size, by stealth, by speed, by the simple fact that it was easier to keep alive. This theory paints Megalodon's extinction as a slow defeat by a smaller cousin. Imagine a heavyweight champion outlived by a featherweight who could just keep coming. The big shark had the muscle, but the small shark had the metabolism. And metabolism wins long fights. For a while, this theory dominated the scientific conversation. It seemed to explain everything: the decline, the disappearance, why great whites survived and Megalodon did not. But the theory has problems. Great whites and Megalodon had coexisted for millions of years before Megalodon went extinct. If competition was going to wipe out the bigger shark, Why did it take so long? Why did the two species share oceans peacefully for an enormous span of time, and then suddenly become incompatible? A more recent study suggests the answer involves the climate again. As waters cooled and prey thinned out, there was no longer enough food for both predators. The competition that was tolerable in rich waters became deadly in scarce ones. Megalodon, with its enormous metabolic demands, could not get enough to eat. Great whites, with smaller bodies and lower needs, made do. The big sharks starved. The small ones survived. Most scientists now believe this is the closest we have to an honest explanation. Climate plus competition. Two pressures squeezing Megalodon from both sides until there was no space left. But the same logic that supports this theory also raises a strange possibility. If Megalodon was being outcompeted in shallow coastal waters, where would its surviving population have to go to escape? Somewhere with no great whites. Somewhere with no killer whales. Somewhere isolated enough that the smaller predators could not follow. The deep ocean fits that description perfectly. Great whites do not go below about 3,000 feet. Killer whales do not stay deep for long. The Hadal zone, the regions below 20,000 feet, has almost no air-breathing predators at all. If Megalodon had any reason to flee its competitors, the deep was the only direction left to flee. We did not just open a door for Megalodon's survival. The deep ocean opened it on its own. Then came the killer whales. Orcas appeared in the fossil record around 6 million years ago, just as Megalodon's reign was beginning to slip. They were small at first, only about 10 feet long. Smart, fast, hunting in coordinated groups. By 3 million years ago, they had grown to nearly the size of modern orcas, around 25 feet long, weighing 6 tons, and hunting in packs of up to 40 individuals. Megalodon had never faced anything like them. A single Megalodon could destroy a single orca. The size difference was too great. But Megalodon was a solo hunter. Orcas were not. They worked together. They communicated. They strategized. Then in the modern ocean, we have already seen what coordinated orca packs can do to large sharks. In 2017, off the coast of South Africa, a pod of orcas began systematically hunting and killing great white sharks. They did not eat the whole shark. They flipped them upside down, induced a state of paralysis called tonic immobility, and then surgically removed their livers. Just the liver. The rest of the body was discarded. Researchers called it the most efficient predatory behavior they had ever witnessed. Now imagine that behavior, 3 million years ago, applied to a young Megalodon. A juvenile shark, not yet at full size, swimming alone in coastal waters. A pod of 40 orcas converging from multiple angles. The young shark cannot fight 40 enemies at once. It cannot outrun them. It cannot escape into deeper water fast enough. The orcas would not even need to kill adults. They would only need to kill the babies. Megalodon nurseries became hunting grounds. Generation after generation, fewer pups survived to adulthood. The species could not replenish itself faster than it was being eaten. This is the slow strangulation theory, and many scientists now think it played a major role in Megalodon's collapse. But here's the twist. If orcas were the killers, if intelligent pack hunters were the reason Megalodon could not survive in coastal waters, then the only safe place left for Megalodon to survive was somewhere orcas could not follow. Orcas need to surface to breathe every 15 to 20 minutes. They cannot hunt at extreme depths for long. The Hadal zones, the deepest trenches, are completely beyond their reach. A Megalodon population that retreated below 5,000 or 6,000 feet would be untouchable by orcas, permanently. If Megalodon survived anywhere in the modern ocean, it would not be where the orcas could find it. It would be where they could not. And that is exactly where we have not looked yet. Of all the theories about Megalodon's extinction, one is so simple it tends to get overlooked. The babies died. Megalodon pups were enormous by modern shark standards. At birth, they were already up to 13 feet long, larger than most adult great whites alive today. But despite their size, they were vulnerable. They could not yet take down full-grown whales. They could not yet hunt in deep, open water. They needed shallow, warm, food-rich nurseries to grow up in safely. Scientists have found these nurseries scattered across the ancient world. In Panama, in Spain, in Maryland, in the Atlantic coast of the United States. Each nursery is identifiable by the same signature: large numbers of small megalodon teeth, only a few inches long, concentrated in shallow marine sediments. Baby teeth. For millions of years, these nurseries worked. Adult megalodons would migrate to give birth in protected bays and coastal lagoons. The pups would grow up over years, eating fish and small marine mammals, gradually building up the size and strength they needed to take on full-grown whales. Then they would leave the nursery and join the open ocean adults. Then the climate changed. As polar ice expanded, sea levels dropped. Coastal lagoons drained. Shallow bays became dry land. The nurseries that had protected megalodon pups for 20 million years simply ceased to exist. There was nowhere safe for the babies to grow up anymore. And it gets worse. In the same period, new predators were colonizing the surviving shallow waters. Killer whales, larger great whites, Pseudorca, the false killer whale. Each of these animals was small enough to enter waters too shallow for adult megalodon. Each could eat a megalodon pup. The remaining nurseries became death zones. Adult megalodons faced a brutal trade. They could leave their pups in cold, exposed waters where they would freeze or starve, or they could leave them in warmer remaining waters where new predators would eat them. There was no safe option left. The species could not reproduce its way out of the trap. This is one of the cleanest extinction narratives in marine biology. It explains why Megalodon disappeared even though adults remained massive and powerful right up to the end. The adults were fine, the babies were doomed, and once the babies stopped surviving, the species had a few generations of decline, and then nothing. But here is where the survival theorists raise their hand again. If Megalodon was driven to extinction because its nurseries collapsed, then any surviving population would have needed a new nursery. Somewhere isolated. Somewhere deep enough to escape orcas and great whites. Somewhere stable in temperature, even as the surface oceans cooled. There are places that fit this description. They lie in zones our submarines have only recently been able to reach. And what lives there has surprised every scientist who has looked. Here is a fact that will not let you sleep tonight. Humans have mapped less than 5% of the ocean floor in any meaningful detail. Less than 1% has been visually explored, meaning a camera or a human eye has actually seen it. The rest is darkness on every map. Empty space, pure unknown. That is bigger than the dark side of the moon. It is bigger than the surface of Mars. And it is right here on our own planet, beneath water we are crossing every single day. The ocean covers about 71% of Earth's surface. Its average depth is more than 12,000 feet. The deepest point, the Mariana Trench, drops to nearly 36,000 feet. That is almost 7 miles straight down. If you took Mount Everest and dropped it into the trench, the peak would still be a mile underwater. This is the world we are claiming Megalodon could not be hiding in. Let that sit for a moment. We have built telescopes that can see galaxies billions of light years away. We have sent rovers to Mars. We have mapped the surface of Pluto. But the deep ocean of our own planet, the place right under our feet, is more mysterious than the surface of the moon. The reason is simple. The deep ocean is one of the most hostile environments in the known universe. At a depth of 20,000 feet, the pressure is more than 9,000 pounds per square inch. That is the equivalent of 50 jumbo jets stacked on top of you. There is no light. The temperature hovers just above freezing. Most of our submarines and probes cannot survive at those depths. The ones that can are large, expensive, and rare. Each dive costs millions of dollars. Each dive lasts only a few hours. Each dive maps only a tiny patch of the seafloor. Scientists estimate it would take more than 100 years of constant exploration to fully map the deep ocean using current technology. We have been trying for less than 100 years total. We are nowhere near halfway. In the meantime, the deep keeps surprising us. In the past decade alone, scientists have discovered new species of sharks, new species of squid, new species of whales, and entire ecosystems built around hydrothermal vents that we did not know existed. They have found cities of giant tube worms, underwater volcanoes spewing black smoke, lakes of liquid brine sitting at the bottom of the ocean like alien terrain. They have also found large unknown shadows on sonar, movements too big to be explained by any known species, sounds picked up by deep-sea microphones that no marine biologist has ever been able to identify. If a 60-foot shark were swimming through these regions right now, would we know? Probably not. We have no eyes there. We have no nets that can handle that depth. We have no consistent observation network in the ocean's deepest places. The argument against Megalodon's survival usually starts with a confident statement. We would have found one by now. But that confidence assumes we have looked. We have not looked. Not really. We have only just begun. The deep ocean has different layers, the way a forest has different floors. Each layer is its own world. Each is more extreme than the last. The sunlight zone goes down to about 600 feet. This is where most ocean life lives. Fish, dolphins, sharks, the world we know. Below that is the twilight zone, where light fades into a dim blue gloom. It stretches from 600 feet to about 3,000. This is where strange creatures begin. Squid that flash with bioluminescence. Fish with enormous eyes. The first goblin sharks. Below that is the midnight zone, 3,000 to 13,000 feet down. Total darkness. The temperature drops to just above freezing. The pressure begins to crush anything not designed to survive it. Life here is rare, alien, and slow. Then comes the abyss, 13,000 to 20,000 feet. The flat plains of the deep ocean floor, cold, dark, and seemingly empty for vast stretches. Most of the seafloor is in this zone. And then, finally, there is the Hadal zone, named after Hades, the Greek god of the underworld. The Hadal zone is where the trenches are, 20,000 feet and deeper. The Mariana, the Tonga, the Kermadec, the Philippine. These are not just deeper versions of the abyss. They are entirely different ecosystems, each one isolated from the others by thousands of miles of higher seafloor. Each trench is its own island of darkness. Each one has been evolving life independently for tens of millions of years. Scientists used to think nothing could live in the Hadal zone. The pressure was too crushing, the cold too severe, the food too scarce. Then, in 2017, a new species of fish was discovered there, the Mariana snailfish, found at over 26,000 feet. Translucent, ghostly, with broad fins that let it glide just above the seafloor. It is now the deepest living fish ever recorded. Other discoveries followed. Giant single-celled organisms called xenophyophories, the size of dinner plates, living on the trench bottom. New species of amphipods, new shrimp, new sea cucumbers that float in the water column instead of touching the floor. Each of these discoveries shocked the scientific community. Each one came from a region that had been declared inhospitable just decades earlier. The Hadal zone is bigger than people realize. The trenches alone stretch for tens of thousands of miles. The total area of seafloor at Hadal depths is larger than Australia, and we have explored almost none of it. Could a megalodon population have retreated to one of these trenches? The cold would be a problem. The food scarcity would be a problem. The pressure would crush the bones of any animal not adapted for it. But adaptation is exactly what evolution does. Over 3 million years, an isolated population could change dramatically. It could become smaller, slower, better suited to the dark. It would not look like the Megalodon we know from fossils. It would be its descendant, its modified, deep water ghost. Most marine biologists doubt this is possible. But every year, the deep ocean gives us another reason to keep the door open. Just a crack. And the next crack is about to open wider. In 2023, a study from UCLA and several other universities reached a startling conclusion. Megalodon was probably warm-blooded. This was not a small finding. Most sharks are cold-blooded. Their internal temperature matches the water around them. They are slower in cold water, faster in warm. Their hunting territory is limited by where their prey lives at the right temperature. But a few sharks today, including great whites, mako sharks, and porbeagles, can keep their internal temperature higher than the surrounding water. They are partially warm-blooded. This lets them hunt in colder regions, swim faster, and stay active longer than other fish. Megalodon, scientists believe, could keep its internal temperature about 13 degrees warmer than the surrounding ocean. That is a huge advantage. It could hunt in colder waters than most predators. It could chase prey for longer distances. It could stay active in conditions that would slow other sharks down. This is the same study that suggested Megalodon's warm-bloodedness might have caused its extinction. Maintaining a high body temperature requires enormous amounts of food. As the climate cooled and prey became scarce, Megalodon's metabolism became a liability. It needed too many calories to survive. But here's the strange thing. Warm-bloodedness also opens up a possibility almost no one has discussed in public. A warm-blooded shark is not limited to warm water. If Megalodon could heat its own body, it could survive in cold, deep waters that would kill a cold-blooded predator. It could descend into the abyss, into regions where the surface oceans are freezing, and still maintain enough internal warmth to keep its muscles working. The deep ocean is cold, just above freezing in most places. A cold-blooded fish there would be sluggish, slow, almost frozen in place. But a warm-blooded fish, with the right metabolism, could move through that water like a ghost, active, hunting, surviving. This does not solve the food problem. Megalodon would still need an enormous amount of calories, but the deep ocean is not as empty as people assume. Sperm whales hunt giant squid down there. Beaked whales dive to 10,000 feet to feed on deep fish. Whale carcasses sink to the bottom, creating temporary food islands that can sustain entire ecosystems for years. A warm-blooded apex predator, smaller than its ancestors, adapted for darkness, could potentially make a living off these resources. The research has not gone there yet. Scientists are still cautious. They want fossils. They want eDNA samples. They want hard evidence before they take this idea seriously. But the warm-blooded discovery quietly changed something fundamental. It removed the temperature barrier. It made the deep ocean a possible refuge instead of an impossible one. Megalodon was already harder to kill than people realized, and the deep ocean was already harder to escape into than science assumed. The two facts fit together in a way that should make us pause. Even if Megalodon could survive the cold and the pressure, there is one question that haunts every survival theory. What would it eat? A modern adult Megalodon would need roughly 100,000 calories per day. That is 20 large whales per year, at minimum. The deep ocean does not have 20 whales per year, per shark. The deep ocean has long stretches of near emptiness, broken occasionally by something to eat. This is the strongest argument against Megalodon's survival, and most marine biologists treat it as the final word. There is simply not enough food down there to feed a 60-foot shark. But the argument assumes a 60-foot shark. If a surviving population of Megalodon had evolved to fit deep water conditions over 3 million years, it would not be the same animal we see in the fossils. It would be smaller, probably much smaller. Maybe only 20 or 30 feet long. Roughly the size of a modern whale shark or basking shark. That is still enormous, that is, but it is also a creature with much lower calorie demands. A 20-foot Megalodon descendant would need only a fraction of the food its giant ancestor required. It could potentially survive on a diet of large squid, deep-sea fish, occasional whale falls, and migrating tuna passing through the deep. This phenomenon has a name in evolutionary biology. It is called insular dwarfism. When a species is isolated from its main population in a smaller, harsher environment, it tends to shrink over time. We have seen it happen with elephants on islands, with deer, with ancient hominids, the so-called hobbits of Indonesia. Smaller bodies need less food. Smaller bodies can hide more easily. Smaller bodies survive when bigger bodies cannot. A deep-water megalodon population would have been under exactly these pressures. The original giants could not survive the food shortages. Their smaller descendants might have. This idea is highly speculative. There is no fossil evidence for it. There is no genetic evidence for it. Most marine biologists consider it a fun thought experiment and nothing more. But the deep ocean has surprised us before. The Coelacanth, when it was rediscovered in 1938, was smaller than its fossil ancestors. The giant squid, when it was finally filmed alive in 2005, behaved nothing like the legend suggested. Living animals always turn out to be different from what we imagined. And there is one more piece of food the deep ocean reliably provides: whale falls. When a whale dies in the open ocean, its carcass sinks to the sea floor. There it becomes a feast that can sustain entire ecosystems for decades. Sharks, eels, worms, crabs, bacteria. A single dead whale can feed deep sea life for 30 years or more. Marine biologists estimate that hundreds of whale falls happen every year in the world's oceans. Most are never observed. They drift down to depths we have never seen, becoming temporary banquets in the abyss. A predator with the right adaptations could follow these resources. Scavenge. Wait. Live a slower, leaner life than its surface-dwelling ancestors. It is a thin thread, but it is a thread. In 2023, the Australian research vessel, RC Fjord Investigator, was conducting routine deep-sea sampling off the western coast of Australia. What it found stopped the entire scientific team in their tracks. At a depth of nearly 17,000 feet, over 3 miles down, the vessel's dredging equipment pulled up sediment full of teeth. Hundreds of teeth. Not modern teeth. Ancient teeth. Fossilized teeth from species long believed extinct. When researchers counted them, they found more than 750 fossilized shark teeth in a single small sample. Some were from species that lived 10 million years ago. Some were from species that lived 20 million years ago. And among them, teeth from Megalodon's closest known ancestor. The discovery raised an uncomfortable question. Why were these teeth there? Megalodon was supposed to have lived in warm, shallow coastal waters. Its teeth should have ended up in coastal sediments, fossilized in the kinds of cliffs and beaches where collectors dig today. They should not be in the deep abyss, 3 miles down, in cold, dark water. But they were. The simplest explanation is that the teeth were carried there over millions of years by underwater currents. Storms washed them off the coast. Tectonic activity shifts the seafloor. Eventually, some teeth end up far from where the shark died. But the simplest explanation has problems. The teeth were too concentrated. Currents tend to scatter fossils across enormous distances. Finding 750 in one small spot suggests something was happening locally. Maybe the sharks themselves were dying there. Maybe they were hunting there. Maybe the deep was their cemetery, not their accidental grave. This would mean that some megalodons, at least, spent time in the deep ocean. That the species was not as restricted to warm shallows as the textbooks insist. that its range extended into regions we have never explored. Scientists are still studying the find. They are cautious. They do not want to overclaim. But the implications are significant. If Megalodon ancestors were dying in the abyss, it means the abyss was part of their territory. And if the abyss was part of their territory, then the deep ocean was always one of their possible homes. Other deep-sea finds have followed a similar pattern. In the Pacific, in the Indian Ocean, in remote trenches off South America. Every few years, scientists pull up another batch of unexpectedly deep Megalodon teeth. Every batch raises the same question. How much of this shark's life happened in places we cannot see? The fossil record we built from coastal cliffs and beach digs may have been only half the story. The other half lies miles below the surface, in sediment we have barely touched. If Megalodon's descendants are still down there, this is the kind of place they would be found. And the deeper we look, the more reasons we have to keep looking. In 1873, a British research vessel called the HMS Challenger was conducting one of the first major scientific surveys of the deep ocean. The expedition lasted 4 years. It crossed every ocean. It mapped sections of sea floor no one had ever seen. It collected samples that scientists would study for the next century. The Challenger laid the foundation for modern oceanography. In one of those samples, dredged from the deep South Pacific, was a single Megalodon tooth. Most of the teeth pulled up by the Challenger were heavily fossilized. They were black, dense, mineralized, typical of a tooth that had been sitting in sediment for millions of years. But this particular tooth was different. Its enamel was lighter. Its mineralization was incomplete. When researchers tested it decades later, they got a result that nobody expected. The tooth appeared to be roughly 11,000 years old. If accurate, that would mean Megalodon was alive during the last ice age, while humans were already painting on cave walls in Europe, while mammoths were still walking across Siberia, while the first farming villages were forming in the Middle East. The idea was so explosive that scientists immediately challenged the dating method. They pointed out that the test used had limitations. They suggested the tooth might have been contaminated by deep-sea minerals that made it look younger than it was. They argued that the result was almost certainly an error. Most likely they are right. The dating method has known issues. The 11,000-year figure is probably wrong. But here's the thing. It has never been definitively disproven either. The original Challenger tooth still exists. It sits in a museum collection in New Zealand. The dating result still appears in a handful of older scientific papers. And every few years, a new generation of researchers stumbles across it and asks the same question. What if it is real? A small number of marine cryptozoologists, scientists who study unverified species, have built their entire case for Megalodon survival around this single tooth. They argue that even if the dating is off by a factor of 10, the tooth could still be only 100,000 years old, still far younger than 3.5 million, still suggesting Megalodon survived past its supposed extinction. The mainstream scientific community dismisses this argument. They say the tooth is ancient, the dating is flawed, the case is closed. But the tooth is not the only one of its kind. In the years since the Challenger expedition, several other Megalodon teeth have been pulled from deep ocean sediment with similar properties. Light coloration, incomplete mineralization, unusually fresh appearance. Each time, scientists have explained the unusual condition as a result of preservation environment. Cold water slows decay. Low oxygen prevents normal fossilization. The teeth look fresh, but they are not. Most experts believe this. Most experts are probably right, but the pattern keeps repeating. Tooth after tooth, dredge after dredge, each one slightly less ancient looking than the last. Each one explained away. Each one quietly added to the growing pile. And every few decades, a sailor or a fisherman finds a tooth so fresh-looking that no explanation seems adequate. The case is not closed. It is just quiet. Throughout the 20th century, sailors and coastal communities have reported strandings of large, unknown sharks. Most of these reports never make it into scientific literature. They are written up in local newspapers, told around docks, passed down through fishing families. A massive shark washes up on a beach in some remote coastal town. Photographs are taken. Maybe a tooth or a fragment of skin is preserved. Then the carcass rots, the tide reclaims it, and the evidence disappears. Some of these stranded sharks have been identified after the fact as basking sharks or whale sharks, large harmless filter feeders that occasionally die and drift ashore. Their decomposing bodies look monstrous, with distorted shapes that fuel rumors of sea serpents and prehistoric survivors. But not all of them. In 1965, on a remote Australian beach, a massive shark carcass washed up. Local fishermen estimated its length at over 40 feet. They reported teeth larger than any they had ever seen. Photographs were taken. Then a storm hit before scientists could arrive. The tide carried the carcass back out to sea. Only a few photographs and one alleged tooth were left behind. The tooth was eventually examined. It was identified as belonging to a great white shark, but a much larger great white than any officially recorded. Some researchers argued the tooth was anomalously large. Others suggested it had been broken or distorted. A few quietly wondered if it was really from a great white at all. Similar reports have come from Japan, the Philippines, South Africa, and the southern coast of Chile. Each report follows the same pattern: a massive shark stranding, photographs that suggest something larger than known species, evidence that disappears before scientists can study it, locals who insist they saw something the textbooks say does not exist. In 1997, off the coast of Mexico, fishermen pulled up a partial shark jaw from the deep ocean. The jaw was estimated to be from a shark over 40 feet long. Marine biologists who examined it suggested it was probably from a great white that had grown to unusually large size. But some of the tooth shapes did not quite match. Some were too triangular, too wide at the base, more like Megalodon teeth than great white teeth. The jaw was stored in a private collection. It has not been re-examined with modern techniques. The original analysis, done with the technology of the late 1990s, was not detailed enough to be definitive. These reports are easy to dismiss. They almost always involve missing evidence, carcasses that disappear, photographs that are blurry, witnesses who are not scientists. The pattern of disappearing proof is itself suspicious. It is what you would expect from hoaxes, exaggerations, or simple cases of misidentification. But it is also what you would expect from real animals that scientists do not have the tools to capture. The deep ocean does not give up its secrets easily. By the time a scientist arrives, the evidence is gone. The reports continue to come in, from fishing villages, from offshore oil platforms, from cargo ships crossing remote waters. Big sharks, bigger than they should be. Sharks that look wrong. Sharks that no one can fully identify. Most are nothing. Most are misidentifications. But some, a small persistent few, refuse to fit into any known category. Off the southern coast of Mexico's Baja California Peninsula, fishermen have spoken for generations about a creature they call El Demonio Negro, the Black Demon. The descriptions are remarkably consistent. A massive shark, dark gray or black on top, white below. Estimated lengths between 40 and 60 feet. A tail so large it can lift a small fishing boat out of the water with a single swipe. Eyes the size of dinner plates. What makes the Black Demon stories different from other sea monster legends is the witnesses. These are not random tourists. These are commercial fishermen who have spent their entire lives at sea. Men who can identify dozens of species of sharks and whales by their dorsal fins alone. Men who know the difference between a basking shark and a great white at 100 yards. And these are the people who say they have seen something else. In 2008, a charter boat captain named Eric Mack reported a close encounter with what he believed was the Black Demon off the coast of Cabo San Lucas. He described a shark longer than his 60-foot fishing boat. The animal swam under the vessel. He could see its outline against the sandy bottom in clear water. He took a photograph that, while blurry, shows a massive, dark shape in the shallows. Mack was an experienced captain with no obvious reason to lie. He had nothing to gain from the story. He stopped giving interviews about it years ago because he was tired of being mocked. In 2015, a group of Mexican fishermen filmed a large dark shape near their boat in the Sea of Cortez. The footage went viral. Most marine biologists identified the shape as a whale shark, possibly viewed from an angle that distorted its size. A few biologists were less certain. The shape did not move like a whale shark. It was too fast, too purposeful. Whale sharks drift slowly through the water column. This thing was hunting something. The Sea of Cortez is one of the most biologically productive bodies of water on the planet. It contains some of the deepest waters along the North American coast. The Cabo San Lucas Trench drops to over 12,000 feet, just miles offshore. Cold, deep water rises to the surface through underwater currents called upwellings, bringing nutrients and prey from the abyss. It is exactly the kind of place where a deep water predator might come up to feed. The mainstream explanation for the Black Demon is that it is an oversized great white shark, or a misidentified whale shark. This explanation works for most cases. For some, it fits less comfortably. The legend persists. The fishermen still tell their stories, and every few years, another sighting is reported, another blurry photograph is taken, another scientist examines the evidence and concludes that something is in those waters that does not match what is supposed to be there. The Black Demon may not be Megalodon. It may not be anything at all, but the people who fish those waters are not making it up out of nothing. They are seeing something real, and they have been seeing it for a long time. What that something is, no one has been able to definitively prove. In 1964, the United States Navy operated a network of underwater listening posts called SOSUS. The system was designed to track Soviet submarines during the Cold War. It used hydrophones, underwater microphones, placed on the seafloor across the world's oceans. SOSUS picked up everything that made noise: submarines, whales, earthquakes, ships passing on the surface. The system could identify a Soviet submarine from thousands of miles away by the unique signature of its propellers. Sometimes SOSUS picked up things that nobody could identify. The most famous example is a sound called bloop, recorded in 1997. Bloop was an extremely loud underwater noise picked up by sensors more than 3,000 miles apart in the South Pacific. Its acoustic signature suggested a biological origin, but it was louder than any animal known to science, louder than blue whales, louder than anything that should exist. Scientists eventually attributed bloop to ice quakes, or large fragments of Antarctic ice breaking off and crashing into the sea. This is the official explanation. It is also the one most often quietly questioned by acoustic specialists who actually listen to the recording. Bloop has biological characteristics. It rises and falls in frequency the way an animal call does. Ice cracking does not behave that way. Bloop is just one of dozens of unexplained underwater sounds recorded since the SOSUS network came online. Submarine sonar contacts have detected large objects moving at depth that did not match any known military vessel or marine animal. Some of these objects were tracked for hours. Some moved at speeds and depths that no living animal was thought capable of. The Navy classified most of these contacts. Some have been declassified in recent decades. A few have been studied by marine biologists, who have been unable to identify what produced them. In 1995, a Russian submarine in the Pacific reported a sonar contact roughly 50 feet long, moving at high speed at a depth of nearly 3,000 feet. The contact appeared on the submarine's instruments for several minutes before disappearing. The crew assumed it was a whale at first. But whales do not stay at 3,000 feet for long. Sperm whales, the deepest diving whales, occasionally reach those depths but cannot maintain them for more than an hour. This contact moved horizontally for several minutes, suggesting steady swimming rather than a brief dive. It was never identified. Similar reports have come from American, French, and Chinese naval vessels. Most are classified. The few that have been released show a pattern. Large biological contacts, 50 feet or longer, moving at depths and speeds that no known shark or whale can match. The contacts are rare. They are usually brief. They almost always vanish before any verification is possible. These reports are not scientific evidence. They are anecdotes from military operators who are trained to identify threats, not biological species. Misidentifications happen. Equipment glitches happen. But the pattern is consistent enough that some marine biologists have started taking it seriously, at least quietly. Something occasionally moves through the deep ocean that does not match what is supposed to be there. It is probably nothing. It is probably misidentified whales, equipment errors, or unusual schools of large fish, but probably is not certainly. And the Navy keeps recording these contacts year after year in waters where Megalodon would once have lived. The most disturbing pieces of physical evidence for Megalodon's possible survival come from whale carcasses. Every few years, a dead whale washes up somewhere in the world with bite marks that puzzle marine biologists. Most of these bites are easily identified. They come from great white sharks, killer whales, cookie-cutter sharks, or various scavengers that worked over the carcass after death. Some bites are harder to explain. In 2004, a humpback whale washed up on a beach in Australia with a massive crescent-shaped bite missing from its midsection. The bite was estimated to be over 6 feet across. No living shark species has jaws that large. Marine biologists examined the wound and concluded it must have been caused by multiple shark attacks, with the bites overlapping to create the appearance of one large bite. This explanation works in most cases. Sharks do feed on whale carcasses in groups, and overlapping bites can mimic the appearance of a single enormous wound. But not always. In 2017, a sperm whale carcass was found floating off the coast of Japan with a similar, massive bite mark. This time the bite was different. The wound was clean, with sharp edges. There was no evidence of multiple overlapping bites. The shape was unmistakably a single, enormous mouth closing on the whale. Researchers measured the bite. They estimated the jaw width at over 6 feet. They examined the tooth marks left in the surviving bone and tissue. The teeth were serrated, triangular, and large. The pattern matched Megalodon dentition almost perfectly. The official explanation was that an unusually large great white shark had bitten the whale, possibly with assistance from other sharks. The unofficial explanation, whispered among the few researchers who studied the carcass closely, was that this bite did not look like a great white bite. The teeth were too uniform. The serrations were too coarse. Great white teeth have a different pattern of serration than what was found. The paper was never published. The whale was disposed of. The few photographs that exist circulate only in obscure marine biology forums. This kind of evidence is everywhere if you look for it. Whale strandings with anomalous bites. Tooth fragments found embedded in modern whale skeletons that do not match any known living species. Massive bite marks reported by researchers studying whale falls in the deep ocean. Most of this evidence is dismissed because it can be explained by other means. Multiple sharks, decomposition distortion, misidentified species. The explanations are not unreasonable. They are probably correct. But some marine biologists have started keeping quiet records. They photograph every unusual whale carcass they find. They preserve tooth fragments when they can. They build a private database of evidence that does not quite fit the textbooks. Most of them will not talk publicly about what they are doing. The professional risks are too high. Anyone who suggests Megalodon might still be alive risks being labeled a crank. Funding dries up. Academic positions disappear. Careers end. So the evidence accumulates quietly, bite by bite, carcass by carcass, year after year. It does not prove anything yet, but it is enough to make some researchers wonder. To understand why scientists are so cautious about Megalodon survival claims, you have to understand the basking shark. Basking sharks are the second largest fish in the world. They can grow up to 40 feet long and weigh over 10,000 pounds. They have huge mouths that they open wide while swimming slowly to filter plankton from the water. They are gentle, harmless, and slow-moving. They are also responsible for almost every modern Megalodon sighting that has ever made it onto the internet. When a basking shark dies, its body decomposes in a strange way. Its softer tissues rot quickly, while its harder parts remain intact. The result is a decomposing carcass that looks nothing like a basking shark. It looks like a long-necked monster, or a giant shark with bizarre features, or a sea serpent. In 1977, a Japanese fishing trawler caught a decomposing carcass off the coast of New Zealand. The carcass was photographed and weighed. It was over 30 feet long. It had what appeared to be a long neck, 4 flippers, and a small head. The Japanese press immediately reported it as a discovery of a living plesiosaur, a marine reptile thought to have been extinct for 66 million years. The story made headlines around the world. The Japanese government issued a stamp commemorating the find. Cryptozoologists declared it definitive proof that prehistoric creatures still survived in the deep ocean. Then marine biologists examined tissue samples. The carcass was a basking shark. The long neck was the spinal column exposed by decomposition. The flippers were what remained of the fins. The small head was the basking shark's lower jaw, with most of the upper jaw rotted away. The plesiosaur sensation collapsed within months. It became a textbook example of how easy it is to misidentify decomposing marine animals, and how quickly the public will latch onto a sensational story. The same thing happens with Megalodon sightings. In 2021, a viral video showed what appeared to be a massive shark circling a cruise ship in the Atlantic Ocean. Millions of people watched it. Tens of thousands shared it. News outlets ran stories asking whether Megalodon had been spotted. Marine biologists identified the shark within hours. It was a basking shark. The video showed the wide, gaping mouth that basking sharks display while feeding. The animal was large, but not impossibly large, well within the range of a normal basking shark. This pattern repeats constantly. Every few years, a new Megalodon video goes viral. Every few years, scientists patiently explain that the animal in the video is a basking shark, a whale shark, or a great white seen at an unusual angle. The cumulative effect is exhaustion. Marine biologists are tired of debunking the same claims over and over. Their patience for new sightings is thin. They tend to assume any claim of Megalodon survival is just another basking shark video, and they dismiss it without serious investigation. This skepticism is reasonable. It is also a problem. Because if Megalodon really does survive somewhere in the deep ocean, the noise of false sightings makes any real signal almost impossible to detect. The boy who cried wolf eventually had a real wolf show up, but by then, no one was listening. If you want to know whether prehistoric sharks can survive in the deep ocean for tens of millions of years, you only need to look at the goblin shark. The goblin shark is one of the strangest animals alive today. It looks like something a horror artist designed in a fever dream. Its skin is a translucent pinkish white, allowing you to see its blood vessels. Its snout is long, flat, and covered in sensors that detect electrical fields from prey. Its jaws can shoot forward out of its head when it strikes, a feature seen in almost no other living shark. The goblin shark is a living fossil. Its closest known ancestors lived around 125 million years ago, in the Cretaceous period, the same era as the dinosaurs. For most of scientific history, goblin sharks were known only from fossils. They were assumed to be extinct. Then, in 1898, a fisherman in Japan caught one in deep water. It was alive. It was real. It had been quietly living in the deep ocean for over 100 million years, and no one had known. Today, scientists believe goblin sharks live primarily at depths between 1,000 and 4,000 feet. They are rarely seen because they almost never come to the surface. The few specimens that have been studied have come from accidental captures by deep-sea fishing operations. We know almost nothing about their behavior, their reproduction, their population size, or their role in the ecosystem. The goblin shark is a perfect example of what could happen with Megalodon. A species that retreated to deep water, became hard to observe, and continued to exist for millions of years while the surface world assumed it was gone. The goblin shark is not the only example. The frilled shark, another deep-sea predator, was thought to be extinct until specimens were caught in the late 1800s. It looks like a snake with shark teeth, and its closest relatives lived around 80 million years ago. We have only ever seen a handful of live specimens, all from accidental captures. The megamouth shark was completely unknown to science until 1976, when one was accidentally caught by a Navy vessel near Hawaii. It is a 15-foot filter feeder with a huge mouth, and it lives in the deep ocean. Before 1976, no scientist on Earth knew it existed. Since then, fewer than 100 specimens have ever been observed. These are sharks living in our oceans, right now, today. Sharks that science either thought were extinct or did not know existed at all. Sharks that can grow to enormous size, live in environments we cannot easily access, and remain almost entirely hidden from human observation. If goblin sharks, frilled sharks, and megamouth sharks can survive in the deep ocean for millions of years without being detected, what makes us so certain Megalodon could not have done the same? The honest answer is size. Megalodon was enormous, far larger than any of the deep-sea sharks we know about. A 60-foot shark needs much more food than a 15-foot one. It would be harder to hide. But evolution, again, could have addressed that. A surviving Megalodon population would have shrunk, adapted, become more like the goblin shark in its lifestyle. A deep-sea predator that surfaces almost never, hunts in waters we cannot see, and leaves behind only occasional traces. It would not be the Megalodon of the fossils, it would be its modern descendant. And we have seen that exact pattern of survival, again and again, with other sharks. The frilled shark deserves its own chapter. It is the closest thing we have to a real-world example of how a prehistoric predator can hide in plain sight. The frilled shark grows to about 6 feet long. Its body is long, snake-like, and gray-brown. Its mouth is filled with 300 trident-shaped teeth arranged in 25 rows. It has frilly gill slits that wrap around its throat, the source of its name. It looks more like a sea serpent than a modern shark. Fossil records of the frilled shark go back at least 80 million years, possibly further. Its body shape and tooth pattern are virtually unchanged from its ancient ancestors. By every standard of evolution, this should be a long-extinct species. It is not. Frilled sharks live today in deep ocean waters around the world. They are most commonly found between 2,000 and 4,000 feet down. They reproduce slowly, with one of the longest gestation periods of any vertebrate. Pregnancies can last over 3 years. They are rare, elusive, and almost never seen alive. The first known specimen was caught in 1884. Since then, fewer than 100 have been observed by scientists. Most have been dead specimens accidentally caught by deep-sea fishing operations. Live-frilled sharks are filmed only every few years, and each filming becomes a major event in marine biology. In 2017, a frilled shark was caught alive off the coast of Portugal. The video of the capture went viral. Scientists called it one of the most exciting deep-sea discoveries of the decade. The shark was studied briefly and released. It disappeared back into the deep, where it presumably continues to live a life that humans will never observe. This is the key point. The frilled shark has been alive for at least 80 million years. It has lived through the asteroid that killed the dinosaurs. It has lived through every climate shift, every extinction event. every change to the ocean's chemistry that has happened since. It has survived because it lives in the deep, eats slowly, breeds slowly, and almost never encounters humans. If you had asked a paleontologist in 1875 whether a snake-shaped Cretaceous shark might still be alive in the deep ocean, the paleontologist would have laughed. The fossil evidence said it was extinct. The biology made no sense. The idea was impossible, and the paleontologist would have been completely wrong. This is the lesson of the frilled shark. The fossil record can be wrong. Extinction is harder to prove than survival. The deep ocean is large enough and weird enough to hide ancient species for tens of millions of years. Megalodon went extinct 3.5 million years ago, supposedly. The frilled shark went extinct 80 million years ago, supposedly. Both are predator sharks. Both have populations that lived in the deep ocean. Both are surrounded by mystery. The difference is that we have caught frilled sharks. We have not caught Megalodon yet. Of all the resurrection stories in biology, none is more famous than the Coelacanth. The Coelacanth is a large lobe-finned fish. It can grow up to 6 feet long and weigh nearly 200 pounds. It has bony, leg-like fins that move in a pattern resembling walking. It is one of the closest living relatives of the fish that first crawled onto land 400 million years ago to begin the lineage that eventually became amphibians, reptiles, mammals, and humans. The Coelacanth, according to the fossil record, went extinct 66 million years ago, the same mass extinction that killed the dinosaurs. In 1938, a fisherman in South Africa pulled up an unusual fish from a depth of about 250 feet. The fish was strange. Its fins moved in unusual ways. Its scales were thick and bony. It did not match anything in the fisherman's experience. A local museum curator named Marjorie Courtenay Latimer examined the fish before it was discarded. She suspected it was something significant. She contacted an ichthyologist, a fish expert, named James Smith. When Smith saw the photographs, he immediately recognized the fish as a coelacanth, an animal that, according to every textbook on Earth, had been extinct for 66 million years. The discovery shook the scientific world. It was one of the biggest paleontological surprises of the 20th century. A creature thought to have died with the dinosaurs was alive in the modern ocean. It had been alive the entire time. Humans had simply never noticed. In the decades since, scientists have learned more about how coelacanths survived. They live in deep water, between 400 and 2,000 feet down. They prefer underwater caves and rocky overhangs. They are slow-moving, long-lived, and nocturnal. They reproduce only every few years, with internal fertilization and live birth. Extremely unusual for a fish. Their populations are small, scattered, and difficult to find. For 66 million years, coelacanths had lived in deep, dark waters around the world. They had adapted to a quiet life. They had hidden in plain sight. And they had completely escaped scientific detection until one accidentally ended up in a fishing net. A second species of coelacanth was discovered in 1997 near Indonesia. Then a third population was found in 2013. Each discovery added to the puzzle. The coelacanth was not just one isolated relic. It was a small scattered family of relics, a network of survivors, and nobody had any idea they existed until 90 years ago. The coelacanth lesson is simple. The deep ocean is capable of hiding ancient species for tens of millions of years. Extinction is a claim that is easy to make and almost impossible to verify. Until you have searched every cubic mile of the ocean, you cannot say with certainty that something is gone. We have not searched every cubic mile of the ocean. We have not searched even a small fraction of it. If a 400-million-year-old fish can survive 66 million years past its supposed extinction without being noticed, what is to stop a 3-million-year-old shark from doing the same? The honest answer is nothing. Nothing is stopping it. Nothing except The sheer improbability of it. And as the Coelacanth showed us, improbable things sometimes turn out to be true. If Megalodon survived somewhere in the modern ocean, what would it look like? Almost certainly, it would not look like the Megalodon of fossils. 3.5 million years is enough time for major evolutionary change. The descendants of any surviving population would have adapted to whatever environment kept them alive. They would be different. Possibly very different. Marine biologists who have engaged with this thought experiment, mostly informally and without committing their careers to it, have suggested some likely traits. It would be smaller. The food scarcity in deep water would force size reduction over generations. A modern Megalodon descendant would probably be 20 to 35 feet long, still enormous, but a fraction of its ancestors' size. About the size of a modern whale shark or a basking shark. It would be paler. Animals living in deep water lose pigmentation because color provides no advantage in the dark. A surviving Megalodon would likely be ghostly white or pale gray, similar to the goblin shark or other deep-sea fish. It would have larger eyes. Deep-sea predators need to gather as much light as possible from the faint bioluminescence around them. Its eyes would be much bigger than the original Megalodons, possibly enormous. It would have a slower metabolism. Deep sea life moves at a different pace. Slower digestion, slower swimming, slower aging. A modern Megalodon might live for 100 years or more, breeding only every few decades. It would be a generalist feeder. Specialization is risky in the deep ocean. A surviving population would have learned to eat almost anything. Squid, large deep-sea fish, scavenged whale falls, occasional surface migrators that wander too deep. Like the goblin shark, it would be opportunistic and patient. It would surface rarely. Most deep-sea animals never come to the surface. They cannot survive the lower pressure. Their organs are adapted for the abyss. A Megalodon descendant would spend its entire life below 2,000 feet, perhaps ranging up to 1,000 feet on rare occasions, but mostly invisible to the world above. This profile sounds nothing like the giant white-bellied predator of the fossil record. It sounds like a deep-sea ghost, a creature that crosses paths with humans almost never, leaves almost no evidence of its existence, and would be so different from its ancestors that we might not recognize it as Megalodon, even if we found one. This is, oddly, the strongest argument for survival. If Megalodon descendants exist, they would be hard to find by definition. If they were easy to find, we would have found them. The fact that we have not found them is consistent with a small, scattered, deep-sea population that has spent millions of years becoming invisible. It is also consistent with a species that simply went extinct 3.5 million years ago and is no longer with us. We cannot tell the difference yet. The deep ocean keeps its secrets. Until we explore more of it, both possibilities remain open. The next discovery could close the question, or it could blow it wide open. In the field of biology, there's a concept called refugia. The word comes from refuge. It refers to small, isolated areas where species can survive when their broader habitat collapses. Refugia are how many ancient species have made it through mass extinction events. Glacial refugia in mountain valleys preserved life through ice ages. Volcanic refugia on isolated islands preserved species through continental upheavals. Hydrothermal vent refugia in the deep ocean have preserved entire ecosystems for hundreds of millions of years. The deep ocean is one of the most stable refugia on Earth. Surface conditions on the planet have changed dramatically over the past 3 million years. Ice ages have come and gone. Sea levels have risen and fallen by hundreds of feet. Continents have shifted. Climates have flipped between warm and frozen states multiple times. Almost no marine species have survived these surface changes unchanged. But the deep ocean has stayed the same. Below about 3,000 feet, conditions on the seafloor barely change. The temperature stays just above freezing. The pressure stays constant. The darkness is absolute. The food supply, while limited, is reliable. Whale falls happen. Squid migrations happen. Seasonal blooms of detritus drift down from the surface in predictable cycles. This stability is exactly why so many ancient species have survived in the deep. The frilled shark, the goblin shark, the coelacanth, the vampire squid, the chambered nautilus, the horseshoe crab. All of these are species whose ancestors lived on Earth during the time of dinosaurs or earlier. All of them found refuge in deep, stable, isolated waters. The same stability could have preserved a population of Megalodon descendants. The argument is not that Megalodon thrived in the deep ocean. The argument is that a small, isolated population could have survived there. Hidden. Slow breeding. Eating just enough to keep the species alive across geological time. Marine biologists call this a relict population. A relict is a small surviving group of an otherwise extinct species. Relics are real. They exist. We have found dozens of them across different branches of life. They are difficult to detect because they are small. They live in unusual places. They almost never interact with the broader world. A relict population of Megalodon would, by definition, be one of the rarest animals on Earth. Possibly only a few hundred individuals, possibly fewer, spread across multiple deep ocean trenches or basins, each individual living for over a century, each generation overlapping with the next. This is the kind of population that could escape detection for millions of years. It could leave behind almost no fossils. It could be impossible to find with current technology, and it is the kind of population that, if it exists, would be one of the most exciting discoveries in the history of biology. The mathematics of relic populations does not prove Megalodon is alive, but it shows that survival is, in principle, possible. The biology works, the geology works, the ecology works. What is needed is evidence. In 1995, a fringe paleontologist named Dr. Carl Schuker proposed something the scientific establishment found ridiculous. Schuker suggested that Megalodon might have survived not as full-sized monsters, but as dwarf descendants. Smaller, faster, deep-water adapted versions of the original. He pointed to the fossil record of declining size in the late Pliocene. The last Megalodon teeth, the ones from just before the supposed extinction, were notably smaller than the teeth from earlier periods. If this trend had continued past the fossil record, surviving megalodons would have kept shrinking, not by choice, but by necessity. Smaller bodies need less food. Smaller bodies handle pressure better. Smaller bodies survive when bigger bodies cannot. The dwarf megalodon idea was dismissed by most paleontologists. They argued that the size decline at the end of Megalodon's reign was probably a sign of stress and starvation, not adaptation. The shark was getting smaller because it was dying, not because it was evolving. But the idea has refused to go away. Recent fossil studies have shown that some marine megafauna did exactly this in response to climate change. They shrank. They adapted. They produced smaller descendants that survived in conditions their larger ancestors could not. We have seen it in deep-sea elephants, in island hippos, in various fish species. The pattern is real, even if it is rare. Could it have happened with Megalodon? The fossil record is silent on this question. There are no known transitional fossils between Megalodon and any modern species. There is no evidence of a dwarf descendant. But the absence of evidence in the fossil record does not necessarily prove absence of the species. Deep-sea fossilization is rare. Deep-sea recovery is even rarer. We may simply not have found the fossils yet. A dwarf megalodon, call it a 30-foot version with the same basic biology adapted for cold deep water, would solve several problems at once. It would explain why we have not found large megalodon teeth in modern sediments. It would explain how the species could have survived on the available food in the deep ocean. It would explain why occasional sightings of large dark sharks fit roughly that size range, rather than the 60-foot monsters of legend. It would also explain something else, why no one has found a body. A 30-foot deep-sea shark, dying and sinking into a deep trench, would leave essentially no trace. The cartilage skeleton would dissolve quickly. The teeth would settle into sediment. The body would be eaten by deep-sea scavengers within weeks. There would be nothing to find. The dwarf Megalodon hypothesis has no direct supporting evidence, but it solves more of the puzzles than the standard extinction story does. It explains the silence in the fossil record. It explains the persistent sightings. It explains the lack of obvious bodies. It is internally consistent. It is, of course, also possible that there is nothing alive down there at all, that all the sightings are misidentifications, that all the strange bites are ordinary multiple feedings, that all the unusual sonar contacts are equipment errors. The honest answer is that we do not know. The dwarf Megalodon idea is unproven. It may always remain unproven, but it has not been disproven either. And the evidence keeps accumulating, slowly, in its favor. If Megalodon descendants survived in the deep ocean, they would have to handle pressure that crushes most surface animals. At a depth of 3,000 feet, the pressure is over 1,000 pounds per square inch. At 10,000 feet, it is over 4,000 pounds per square inch. At 20,000 feet, it is nearly 9,000 pounds per square inch. At the deepest parts of the ocean, the pressure exceeds 16,000 pounds per square inch. For comparison, the pressure inside a human body at the surface is about 15 pounds per square inch. The pressure at the bottom of the Mariana Trench is over 1,000 times that. Any animal not adapted for the deep would be crushed instantly. But adaptation is possible. The deep ocean is full of animals that thrive at extreme pressures. They have specialized cell membranes that resist compression. They have proteins shaped to function under crushing forces. They have body fluids that maintain neutral pressure with their environment. None of these adaptations are impossible. They have evolved repeatedly across many different species. Could a megalodon have made this transition? The answer depends on time and selection pressure. Megalodon was not built for the deep ocean. Its skeleton was cartilage, which is more compressible than bone, but not adapted for hadal pressures. Its organs were structured for surface conditions. Its hunting style, rapid bursts of speed to ram and bite large prey, is not suited for the slow-motion world of the abyss. But 3.5 million years is a very long time for evolution to work. Cartilage can be modified. Organs can be reshaped. Hunting strategies can change completely. The selection pressure on a surviving population would be intense. Only the individuals best adapted to deep conditions would breed, and over many generations, the species would shift toward deep water specialization. There is precedent for this. Some sharks today, like the blunt-nosed six-gill shark, regularly dive to depths over 5,000 feet. They handle the pressure changes with apparent ease. Their bodies are slightly different from surface sharks, denser, more compact, with adaptations that allow them to move freely between surface and deep waters. A megalodon descendant could theoretically have followed the same path, started with occasional dives, spent more and more time at depth as surface conditions deteriorated, eventually become permanent deep water residents, each generation slightly better adapted to pressure than the last. The timeline works. The biology works. The selection pressure was certainly present. What remains is whether it actually happened. We have no fossil evidence either way. We have no living specimens to study. We have only the theoretical possibility. This is the frustrating thing about megalodon survival theories. Almost everything about them is theoretically possible. The cold could be handled. The pressure could be handled. The food shortage could be handled. The competition could be avoided. The geographic isolation could provide refuge. Each individual challenge has a plausible solution. The problem is that all of them would have to happen at once. The species would have to adapt to pressure, cold, food scarcity, and pressure all simultaneously across millions of years, while also avoiding every other predator and every other threat. The cumulative probability is small. Small but not zero. The frilled shark managed it. The goblin shark managed it. The Coelacanth managed it. The list of impossible survivors keeps growing. Megalodon could be on that list, or it could not. The deep ocean has the answer. We just have not asked it yet. This is the kind of question that gets dismissed as conspiracy theory, but it deserves a serious look because the implications are fascinating. If Megalodon descendants exist in the deep ocean, they would have to be eating something. Deep-sea predators are opportunistic. They take what is available. And in the modern ocean, something has been swimming through their waters for the past 100 years that did not exist before. Submarines. Modern military and research submarines operate at depths up to about 1,500 feet for most vessels, with some specialized models reaching 2,000 feet or deeper. Their sonar emissions, their electromagnetic fields, and their general presence would be detectable to deep-sea sharks. Sharks have ampullae of Lorenzini, special organs that sense electrical fields in the water. They can pick up the faint electrical activity of a beating heart from yards away. The huge electrical signature of a submarine would be impossible to ignore. Whether a Megalodon descendant would attack a submarine is an interesting question. Most deep-sea predators are cautious. They would investigate something new, but they would not necessarily attack something so much larger than typical prey. A modern attack submarine is over 300 feet long. Even a large Megalodon descendant would think twice before attacking something that size. But there are reports. Throughout the Cold War, both American and Soviet submarines occasionally reported strange impacts at depth. Most were attributed to debris, to schools of large fish, or to equipment malfunctions. A few were unexplained. The submarine would feel a sudden bump or scrape against the hull. Sonar would briefly show a large object moving away. The crew would inspect the hull at the next port and find no damage. These reports are extremely rare. Most are probably explained by mundane causes. Submarines hit things. Whales bump into vessels. Equipment glitches happen. But a few reports stand out. In 1967, an American attack submarine reported a sustained scraping along its hull at a depth of nearly 2,000 feet. The sound lasted for almost a minute. When the submarine returned to port, technicians found a series of parallel grooves cut into the rubber acoustic tiles on the outside of the hull. The grooves were spaced apart in a pattern consistent with teeth. The official explanation was that the submarine had brushed against a school of large fish, possibly tuna or a large shark, that had scraped the tiles with its teeth as it tried to bite or investigate the strange object. The investigation was quietly closed. The grooves were photographed, but never publicly released. The story circulated only through naval gossip channels. Similar reports have come from other navies. Always quietly. Always classified. Always officially attributed to mundane causes. But the reports keep happening. Most likely these are misidentifications. Sharks do investigate submarines. Whales do bump into them. Equipment does fail in odd ways. But the possibility remains that occasionally, in the deep, dark waters where submarines patrol, something larger and stranger investigates them too. Something that leaves marks the official record cannot quite explain. If Megalodon descendants are out there, they are almost certainly in the same waters where our military submarines operate. Whether they have ever interacted, we may never know. The submarines that come back report what they think they saw. The submarines that do not come back report nothing at all. The most promising new tool for finding hidden species is environmental DNA, or eDNA. Every animal sheds genetic material into its environment constantly. Skin cells, mucus, waste products, bits of tissue. This DNA enters the water and persists for a period of days to weeks before degrading. By collecting water samples and analyzing them for genetic traces, scientists can detect what species have recently been in an area, even without seeing the animals themselves. The technology has revolutionized marine biology. Scientists can now sample a coral reef and identify hundreds of species from a few liters of water. They can detect rare or invasive species that have never been observed visually. They can monitor populations of elusive deep-sea animals without ever seeing them. In 2017 and 2018, two separate research groups announced they would use eDNA to search for evidence of Megalodon. The plan was simple. Collect water samples from deep ocean locations where Megalodon descendants might plausibly live. Test the samples for DNA sequences matching Megalodon's known genetic profile, derived from analysis of the species' closest known living relatives. The results, when they came in, were disappointing. No Megalodon DNA was found in any of the tested samples. The water contained genetic traces of sperm whales, large squid, various deep sea sharks, and many other species, but nothing that matched Megalodon. Skeptics took this as confirmation that Megalodon is extinct. If it were alive, they argued, we would have detected its DNA. The technology is sensitive. The sampling was extensive. The absence of evidence is, finally, evidence of absence. Survival theorists responded with several counter-arguments. The sampling, while extensive by historical standards, has covered an extremely small fraction of the deep ocean. The vast majority of potential Megalodon habitat has not been sampled. Just because no Megalodon DNA was found in the few samples taken does not mean it does not exist. They also pointed out a more technical problem. DNA degrades quickly in seawater. To detect a species, you need to sample water that recently held that species. If Megalodon descendants are extremely rare, the chance of sampling water that recently passed by one is vanishingly small. Even if they exist, finding their DNA would require either extreme luck or a comprehensive sampling program that does not yet exist. A few researchers have started designing better eDNA studies. They want to focus on areas where Megalodon descendants would most plausibly live. Deep trenches, isolated basins, regions with unusual sonar activity. They want to use specialized DNA detection kits tuned to the closest possible Megalodon genetic profile. They want to sample over multiple years, repeatedly, to build a comprehensive picture. These studies are expensive. Funding is limited. Most marine biology grant committees are reluctant to support research aimed at finding extinct species. The work proceeds slowly, mostly funded by enthusiast organizations and private donors. But the technology continues to improve. Each year, eDNA sensitivity increases. Each year, the cost decreases. Each year, the geographic coverage expands. If Megalodon descendants exist, eDNA is probably how we will find them. Not through a sighting, not through a body. Through a tiny scrap of genetic material drifting in cold, dark water, picked up by a passing research vessel, analyzed in a lab somewhere, and matching a genetic signature that no living shark should have. It has not happened yet. But each year, we get closer to the technology that could detect it. The hunt is on, even if most scientists are pretending it is not. It would be dishonest not to acknowledge where the scientific consensus stands. The vast majority of marine biologists, paleontologists, and shark researchers are convinced Megalodon is extinct. They have good reasons for this conviction. The fossil record is clear at the broad scale. Megalodon teeth appear in every continent except Antarctica during the Miocene and early Pliocene. They thin out steadily through the late Pliocene. They stop appearing around 3.5 million years ago. After that, nothing. No teeth in younger sediments, no bite marks on younger whale fossils, no evidence of any kind that the species continued to exist. This pattern is unusual. Most species do not vanish so cleanly from the fossil record. Most extinctions leave a fuzzy edge. Late survivors, isolated populations, gradual disappearance over time. Megalodon's disappearance is sharper than most. It looks like a true extinction event, not a retreat. Modern observations support this. If a 60-foot shark were alive in the modern ocean, even in deep water, we would expect to see evidence. Whale carcasses with definitive Megalodon bites, teeth in fishing nets, photographs from deep water cameras. The hundreds of thousands of underwater observation hours we have accumulated should have produced something definitive by now. They have not. Marine biologist Emma Bernard at the Natural History Museum in London has stated clearly and publicly that Megalodon is not alive. She points out that an animal as large as Megalodon would leave obvious traces, telltale bite marks, distinctive teeth, sonar contacts that match the species' size and shape. We have none of these. Stephen Godfrey, a paleontologist at the Calvert Marine Museum, makes a related argument. Megalodon was a surface predator. It hunted in the photic zone, the upper layers of the ocean where sunlight penetrates and prey lives. The deep ocean does not have enough food to support a giant predator. If Megalodon retreated to the deep, it would have starved. The biology does not allow for the survival scenario. These arguments are strong. They reflect mainstream scientific thinking. They are based on solid evidence and careful reasoning. The position of mainstream marine biology is that the Megalodon survival theories are romantic, but unsupported. They reflect human reluctance to accept that a magnificent predator is gone. They reflect the seductive mystery of the deep ocean. They reflect our species' fondness for monster stories. But they do not reflect what the scientific evidence actually says. The evidence says Megalodon went extinct. The deep ocean has been searched, sampled, and observed enough times to make survival extremely unlikely. The remaining gaps in our exploration are large, but not large enough to hide a 60-foot shark from every research vessel, every fishing fleet, every Navy submarine. This is the considered professional view of the people who know the most about the topic. It is probably correct. Probably. But probably is not certainly. And the scientific consensus has been wrong before. About the Coelacanth, about the giant squid, about the megamouth shark, about the giant tube worms at hydrothermal vents, about entire ecosystems we did not know existed until we accidentally found them. The mainstream view is the most likely to be correct. But the deep ocean has a long history of humbling people who claim certainty about it. There are scientists, a small minority, who do not entirely close the door on Megalodon survival. They do not advertise this position. It would be career suicide. They do not write papers arguing for Megalodon's continued existence. The evidence is not strong enough to support such a paper, and the professional consequences would be severe. But in private conversations, in late-night discussions at conferences, in carefully worded comments to trusted colleagues, they admit that they are not entirely certain. These scientists tend to share certain characteristics. They have spent significant time in the deep ocean. They have personally seen things that science cannot explain. They have worked with the limits of marine biology long enough to know how vast those limits are. One example is the paleontologist Dirk Hovstadt, who has studied Megalodon teeth for decades. In published papers, he supports the standard extinction narrative. In private, he has acknowledged that some of the teeth he has examined display unusual features, patterns of mineralization that do not quite fit the expected fossilization timeline. He does not claim these teeth are recent. He simply notes that they are puzzling. Another is the deep-sea researcher Edith Witter, who has spent her career observing animal life in the deep ocean. She has seen creatures no one knew existed. She has watched the deep surprise scientists over and over again. In interviews, she has been careful not to commit to any Megalodon survival claim, but she has also said, repeatedly, that the deep ocean still holds enormous unknowns. She refuses to make confident statements about what is or is not possible down there. A handful of cryptozoologists, researchers who study unverified species, have been more direct. They argue that the evidence for Megalodon's continued existence, while circumstantial, is not negligible. They point to the unusual teeth, the unexplained sonar contacts, the persistent sightings, the deep sea finds. None of these alone proves anything. Together, they form a pattern that they find difficult to dismiss. Cryptozoologists are not taken seriously by mainstream science. Their field has a reputation for accepting weak evidence. Most of their claims have turned out to be wrong, but not all of them. The mountain gorilla was once a cryptozoological claim. The okapi was once a cryptozoological claim. The giant squid was once a cryptozoological claim. All of them turned out to be real. The deep ocean is the most fertile ground for cryptozoology in the modern world. It is also the place where mainstream science has the least direct knowledge. The combination produces strange disagreements. Mainstream researchers know the most about the surface evidence. Cryptozoologists pay the most attention to the anomalies. Both groups are looking at the same world, but they are looking at different parts of it. The handful of mainstream scientists who quietly acknowledge uncertainty about Megalodon are stuck in the middle. They cannot fully support the cryptozoologists because the evidence is not strong enough. They cannot fully agree with the mainstream consensus because they have personally seen things that make them less certain. So they keep quiet. They keep doing their work. They keep collecting data. They keep their personal doubts to themselves. If Megalodon descendants are ever conclusively proven to exist, these are the scientists who will say, gently, that they had wondered. They had not been certain. They had kept the door open just a crack. For now, the door is just barely open. A sliver of light. Enough to keep the question alive. What happens next depends on what the deep ocean reveals. Imagine the news. A research vessel in the South Pacific pulls up something extraordinary. Footage from a deep submersible, or a body washed up on a remote beach in the Philippines, or a tooth, a fresh, pearl-white, shark tooth, nearly 7 inches long, pulled from the stomach of a sperm whale that died of natural causes. The first announcement would shake the world. Within hours, the news would be everywhere. The story would dominate every channel for weeks. Scientists would scramble to confirm the find. Governments would issue statements. Marine biology departments would be flooded with applications. Funding for deep-sea exploration would multiply overnight. The scientific implications would be staggering. Megalodon's survival would force a complete rewriting of marine biology textbooks. It would prove that the fossil record is more incomplete than scientists have admitted. It would suggest that other supposedly extinct species might still be alive. It would launch a new era of deep-sea exploration unlike anything we have seen. The cultural implications would be even bigger. The modern world has grown comfortable with the idea that we know our planet. We have mapped its surface. We have identified its species. We have categorized its ecosystems. Megalodon's reappearance would shatter that comfort. It would prove that the Earth still has secrets. Big, important secrets, swimming through waters we cross every day. For some, this would be terrifying. The ocean would feel less safe. Beach vacations would seem riskier. Cargo ships and fishing boats would worry about encounters that could destroy them. A creature with a 40,000-pound bite force, even a smaller modern descendant, would be the most powerful predator in any environment it entered. For others, the discovery would be the most exciting event of their lives. Proof that the unknown still exists, that the Earth has not been fully tamed, that mystery still has a place in the modern world, that the deep ocean is bigger and stranger than we ever knew. The scientific community would be split. Some researchers would celebrate the validation of decades of quiet doubt. Others would feel professional embarrassment at having been so confident in extinction. The field would reorganize itself around the new reality. Conservation efforts would begin immediately. A relict megalodon population would be the rarest large animal on Earth. Possibly only a few hundred individuals worldwide. Possibly fewer. Each individual living for a century or more, breeding rarely, producing few offspring. The species would be incredibly fragile despite its size. Protecting it would become an international priority. Tourism would explode. Diving operations would offer megalodon expeditions, even if the chances of seeing one were extraordinarily low. Submarines would be booked years in advance. Coastal towns near megalodon habitat would become destinations. The shark would become the symbol of deep ocean wonder. But all of this depends on the discovery actually happening. And as of this moment, it has not. Megalodon is still officially extinct. The deep ocean is still officially empty of giants. The textbooks are still mostly unchanged. The question of whether Megalodon survives is, for now, a question without an answer. The evidence on both sides is real, but inconclusive. The technology to settle the question is improving, but not yet sufficient. The scientific consensus is strong, but not unanimous. Something is down there. Maybe many things. Some we know. Many we do not. The deep ocean keeps its secrets, generation after generation, while the human world above it changes everything except the dark waters below. Megalodon may be dead, or Megalodon may be alive, ancient, deep, and waiting. The next time you stand at the edge of the sea, look out at the horizon and think about this. Most of what is beneath that water has never been seen by human eyes. Most of what lives in it has never been counted. The largest predator in the history of the world may be gone forever. Or it may still be down there, hunting in the dark, 3 miles below the surface where no one has ever looked. The ocean knows. It is just not telling.